Hi guys, welcome back to the day 9 of Python series. So today's concept is list comprehensions and lambda functions in Python. So this is very crucial concept and it is a gateway to advanced Python coding. So let us go very deeply into this concept. So here are the reasons why to master these concepts. These are very essential for the interviews and these are readable and concise. This will boost our performance in interviews more than using often. These are used often to execute faster than traditional loops, and these are favorites for coding round. So in coding rounds, these are the frequently asked questions, also in technical rounds also. So writing cleaner and elegant Pythonic codes use these concepts. So this will help in crucial problem solving and efficiently work in competitive programming also. So the first concept of today's session is list comprehension, which is a feature which allows us to create a new list from the existing ones in a single and compact line of code. So it is essentially syntactic sugar for loop and conditional statements. The basic and the simple definition for the list comprehension is a concise way to create lists. So here is the syntax: expression for item in iterable if condition. So expression is required for generating the sequence of numbers, for loop to traverse through the sequence of numbers, if condition to check whether the expression condition satisfies the existing number of iterable sequences or not. So comparison, it replaces multi-line loops, making code more readable and efficient, and it makes the space complexity very efficient rather than compared to loops actually. So here is the basic example of list comprehension. So this is the traditional loop approach to create the square numbers. So here we have to take the numbers and we have to create the list, and we have to work on the square numbers and we have to append the value to the list, and finally we have to print the list. Here no need of such these three lines. So we are performing these three lines in a single line using list comprehension. So here we are taking the input as numbers 1, 2, 3, 4, 5. So here we are creating a new list of squared of the numbers. So here is the expression num asterisk num, which is num square for for the variable in numbers. For the variable in the iterable sequence. So numbers means here is the iterable sequence, which is a list. So here we are performing the squaring of the numbers list. So it will automatically get stored. 1 square is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. These values get stored in a squared of numbers and get printed when we call the function of print of squared numbers. So we can achieve the same result in single and elegant line. So this approach is clear, but very large, very enhanced way is list comprehension. This is the traditional approach which we used in loops. So conditional list comprehensions. So here it is used to create even numbers. If the number is divided by 2, then it's called even. So number is the expression, and for numbers in for number in numbers, numbers are iterables. And here is the if condition: if the number is divided by 2, then it is considered as even, and those numbers which satisfy the if condition will be stored in the even numbers list. So in the list of 1 to 10 numbers, the even numbers are 2, 4, 6, 8 and 10. So this will be stored. So this will be helpful in solving the complex problems. So here is an interview example of filtering the prime numbers. Let us go with the sequence flow. So it will go with the first line, which is def is prime of m, and it will directly go to the, wait a minute, 1, 2, 3, 4, 5, 6, sixth line, which is numbers list. So it will check whether the given number is prime or not. So it will go with primes equals to number number n for n in numbers, which is iterable sequence numbers, if e is prime of n, if e is prime of n returns true, the value will be stored into primes list, otherwise it will not. So it will, when it is called, it will go to the function and checks the each and every iterable sequence, and if the number is less than 2, it will directly return false and it will not be stored in the list of primes. So if the numbers is in the range of 2 comma square root of the number plus 1, it will check for if the number is divided by range of I numbers is not, other it will return false, otherwise it will return true, which make us simple for creating a prime numbers list using the list comprehensions. So mastering the nested comprehensions. So we can also perform nested lists using this list comprehensions. Here is for matrix transformation. So we are performing we are shifting the rows into columns and columns into rows. So here is the matrix with 3 by 3 matrix 1 2 3 4 5 6 and 7 8 9. So the transpose matrix is created using row of I, which means row of initial number for row in matrix. So for I in range of 1 comma 3, um, first this will the outer part will be working. So for I in range of 3 means the first number is 0. So first row of 0, it will consider the row of 0. For row in matrix, then it will again go with the outer statement. It will get transposed into rows will get be transposed into columns, and columns will be transposed into rows. So this will help us to do matrix transformation using a single line of list comprehension code. And here is the flattening of list using a list. Convert a list of lists into a flat single list. So list of lists is a nested list. So we are converted into a single list. So item for item is the expression for sublist in list of lists. Here the list of lists or nested list is a iterable sequence, and for item in sublist is nested list comprehension, which offers a compact solution. So here it will get printed as a single list using the flattening method. So, and one more thing is we use lambda functions also. So these are the practice problems to sharp our skills using list comprehensions. So here are the here are the outputs for these functions also. In codes also. So creating a list of square of numbers from 1 to 10. So we take the range from 1 to 11, which performs from 1 to 10, excluding the value 11, and filtering the odd numbers from the given list. We check if the number is not divisible by 2, then it is automatically considered as odd number, and converting the list names into uppercase. So name we use the single statement, that is name dot upper, which is a string function used to convert to convert the given string into uppercase values. So these will be the practice problems which we can practically do after the completion of this session. So next is demystifying the lambda functions. So lambda functions are small anonymous functions defined with the lambda keyword. These are also known as single expression keywords functions. So they don't have any name. The syntax is lambda, arguments, and expression. So for example, it can be used in creating the square of numbers also. So the use case is they are primarily used for short throwaway functions, especially as arguments to higher order functions. So here is the simple example to adding of two numbers, basic lambda examples. So here we add the two numbers a plus b in the single line. So this will be helpful as a function which is created in a single line and very concise and very helpful also. This is very a compact way to define an addition function. So these numbers are will be wait a second. These numbers will be gone. I mean transferred into a and b, and the operation is performed as an expression, and the result will be stored in the result, and the result will be get printed using the print statement. So another example is squaring a number using the expression x square, that is x hashtag x. So the output is printed according to the given input. So these are performing perfect single expression calculations. So lambda power with higher order functions. So we use inbuilt functions like map, filter, and sorted with the help with additionally with the lambda functions. So here are the numbers. So using the map, we list. We create a list using the lambda function x with the numbers. I mean, for 1 it is mapped with 1, for 2 it is mapped with 4, for 3 it is mapped with 9, and for 4 it is mapped with 16. So, and the lambda using filter, we use, I mean, it constructs an iterator from elements which a function returns true. So it creates an iterator, which means a list from the elements for which the function is true. So if x percentage 2 is, x is divided by 2 equals to 0, then it is even, right? So the even numbers will automatically get stored with using the filter function, skipping the if condition. So the print statement of even numbers will get print the even numbers from 1 to 6 as 2, 4, and 6 respectively. The next one is sorted. Sorted, this is a function used for sorting sorting a list based on custom key. So key equals to lambda s dot s of 2. So wait a second, s of 2. So this is a custom key defined here, which is Jane B. The value of tuple Jane B and 12. So these are sorted by the age. So that's why here the custom key plays a key role in sorting a list based on the sorted function using the lambda. So that's it for today's class. Let us go with some practice problems. Creating a list of cubes is the first problem of today's session. So L equals to 1, 2, 3, 4, 5. C cubes equals to lambda x. One second. List of map of lambda. Sorry for the disturbance. Next dot x power x power 3. So let us see. Let us check with let's check with the output. Print C So it is successfully printing the output as 1, which is the cube of 1, 8, which is the cube of 2, 27, which is the cube of 3, 64, which is the cube of 4, and 125, which is the cube of 5. So let us go with the next problem. Filtering the odd numbers, which we have already seen. So n equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Odd equals to list of filter of lambda x such that x percentage to not equals to 0, comma a triple sequence. Now let us see the output. Print odd. Let us check. Right syntax. Sorry, we have given the spelling of lambda as well. The odd numbers of the list 1 to 10 are filtered using the filter function associated with lambda. So let's go with the another question of today's practice session. Multiply all the elements by 3. So n equals to list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So L equals to list of lambda x such that let us map the list first. List of map of lambda x such that x asterisk 3 comma n. Now let us print the list. Print L. Let us run it. So it will get the output as the three table 3 1s 3 3 2 6 3 3 9 3 4 12 3 5 15 3 6 18 3 7 21 3 8 24 3 9 27 3 10 30, and convert the list into uppercase, which you have already seen in the list comprehension. So s equals to list of Pawan, Harsha, Pujit. So L equals to list of map of lambda x such that x dot upper comma s print L. Now let us see whether the function works or not. So each and every single letter of the each string is converted into uppercase. So these are the functions today. These are the practice problems of today's session. And the main common mistakes which you need to avoid is overusing of lambda and writing complex and unreadable comprehensions and forgetting list while using the map or filter functions associated with the lambda comprehensions. And why to use this is for efficient data processing and for frequent interview problem solving and writing a clean code, working with data sets. So these are the most common uses used and helpful while using lambda functions with list comprehensions. So that's it for today's session. Meet you in the next class with another concept. So please like, share and subscribe to my channel. Learn with Pawan. Meet you then.